Hello everyone, and welcome to Jam Academy. In this very nice problem, we have a squirrel at rest, drops a nut from a tree branch 100 meters above the ground. How fast is the nut moving when it reaches the ground? And we are required specifically to use the Work Kinetic Energy Theorem. Now, the Work Kinetic Energy Theorem basically states that the net work done on an object is equal to the change in the kinetic energy of that object. Now, in order for you to apply the Work Kinetic Energy Theorem, it is essential for you to choose 2 points, the initial and the final point, and the choice is yours. In this particular example, I'm going to choose the point where the nut is dropped by the squirrel, and point B will be the point where the nut is just about to hit the ground, which is the point where we want to calculate the velocity. Now, the next question is, what is the force that does work on the nut? In order for you to see this, you have to draw a free body diagram. Drawing a free body diagram, you see that the only force that acts on the nut is the force of gravity that acts vertically downwards. The nut is also moving vertically downwards, which means that the work done by gravity on the nut is positive. If the work done by gravity on the nut is positive, by the Work Kinetic Energy Theorem, the speed of the nut increases as it falls, which is normally what we observe. So, the net work done will be equal to the force of gravity multiplied by delta y. This is equal to m, well, this is cosine of theta. This is equal to mg multiplied by h, because delta y is h, cosine of 0, and this is equal to mgh. So this is the net work done on the object. Beautiful. At point A, the nut is dropped from rest, which means that the speed at A is 0. What about B? The speed at B is the speed that we are looking for. But the good news is the net work done, mgh, is equal to the final kinetic energy, half mvb squared minus 0. In other words, we can see that 1/2 mvb squared is equal to mgh. The masses will cancel, and v sub b will be equal to the square root of 2gh. This is the expression to calculate the speed of the nut at B. In other words, Vb is equal to the square root of 2. G is 9.8 meters per square seconds. G is 100 meters. 9.8 multiplied by 10, that will be 98 times 10, that would be 980 times 2. So the speed at B will be 44.3 meters per second. 44.3 meters per second. Please, if you have any questions regarding how we've done this problem, I will appreciate it if you ask in the discussion forum below this video. It is absolutely important that you participate in this discussion. If you've understood, put a comment. If you have a concept that you're having trouble with, add a comment, and we should be able to help you. Thank you so much, and continue having fun in this class. Bye-bye.